Namaste everyone. My name is Tejas. We are from Space Academy. So today we'll be discussing about earthquakes. When we hear the word earthquakes, so usually it's a very big natural disaster, right? But from UPSC's point of view, we have to go into some subtle details. So what exactly is an earthquake? First we'll start with a definition. Okay, so and to understand this definition, let's understand the phenomena first. So the earthquake is a sudden release of energy which happens because of the crustal breakage of rocks, right? And the point where this breakage of rocks happen, there is a huge amount of energy which is released. The point at which this energy is released is called as the hypocenter, which is also called as a focus. Now, from this hypocenter, the energy goes up and up and up, and finally it reaches the surface of the earth. So, when it reaches the surface of the earth, the point at which it reaches the surface, and that is the impact point on the earth, is called as the epicenter, right? So hypocenter in the bottom where the crustal breakage happens and epicenter on the top. Okay. So now when we come to the definition, nothing already what we have learned. Sudden release of energy which happens because of the crustal breakage of rocks and the impact which is felt, that's what is called as an earthquake. So earth is quaking, right? So what exactly is the sudden release of energy? We measure it through some waves. Okay, so this is called as earthquake waves. We broadly categorize these earthquake waves into two types. One is the body waves and the second is the surface waves. The body waves are further classified into primary waves and secondary waves. And the surface waves are classified into love waves and Rayleigh waves. Now, the body waves, first we'll talk about the primary waves, right? So, what exactly is this primary waves? They are perpendicular to the direction of propagation. Big words, nothing to worry. Okay, so perpendicular to the direction of propagation means, like, imagine that this is a building. Now, in this building, okay, this is the earthquake waves which come. The building just moves up and it goes down. So it's the slight tremor which is felt. Usually we might have noticed this in our homes. Suddenly when this is the slight tremor, all our relatives, they carry the babies outside the road because they anticipate that something next, something more bigger is going to come. That is nothing but the secondary waves, right? One more thing about the primary waves is that it can pass through solids, liquids, and gases. So almost very similar to sound waves. Next is the secondary waves. Secondary waves are these are these can only pass through solids and they are a little later after the primary waves arrive. That is, there is a time lag between when the primary waves make contact and the secondary waves make contact. And these secondary waves are more powerful than the primary waves. They are perpendicular to the direction of propagation. Meaning to say that if this is a building, they hit it so hard, okay, so sometimes the buildings shake and sometimes weak buildings, old buildings might even fall down, right? But there is a little more time lag, and that is when the surface waves make impact. Okay, so that is when the love waves and Rayleigh waves make impact. If you ask guys, which is the most destructive in all of the world, okay, be it earthquakes or otherwise, which is the most destructive? Love waves are the most destructive, right? So, anyways, so coming back, how do we measure these earthquakes? These earthquakes can be measured by two scales. One is called as a Richter scale. These Richter scales are used to measure the magnitude of the earthquake. Now, how do we measure what exactly is this magnitude of this earthquake? It is nothing but how much of energy is released. Okay, so this Richter scale is a log scale. There is gradations like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But so many times, what do I mean by it's a log scale? So many times we would have noticed that there is a Richter scale reading of 6 and we see that everything is normal, there's some slight tremors. But when we see a Richter scale reading of 7, we see everything is destroyed. That is because between 6 and 7 there is 6.1, 6.2, 6.3, 6.4. So every time there is a 6 to 7 increase, that is there is just one increase, actually the increase is 10 times. That is what is a logarithmic scale or a log scale. Now we go to the second scale, which is called as a Mercalli scale. Now what exactly is this Mercalli scale? This Mercalli scale measures the intensity of earthquake. Intensity of earthquake takes into account the visible damage which is caused. Visible damage meaning, imagine that the earthquake happens in a forest. Now, inside this forest, there is almost nothing. There's no buildings, there's no property there. So, earthquake, even if it's like, let's say, Richter scale 7, there's almost no visible damage. So, the Mercalli scale reading will be very low. But imagine it happens in a populated city like, let's say, Bangalore, Chennai, Mumbai. That time, the visible damage is a lot. There would have been a lot of property damage. So that time, the Mercalli scale reading would be very high. Now we come to the last sub-concept of these earthquakes. We understand this, we are good to go. So what is this last concept? It's called as a shadow zone. Now, anytime there are these different like India has Indian meteorological department, different countries have different meteorological departments. And what do these departments do? These departments, they measure how earthquake readings are there and they study these natural disasters. So these small tremors keep happening all throughout, every time, every day, everywhere. Something which is of little significance can be recorded. Like, let's say something happens in Europe, it can be recorded in India. Okay, now how does something which happens somewhere in Europe can be recorded in India? That is because imagine that one earthquake tremor, okay, it goes through somewhere else and in India it is recorded. Now imagine that this is the earth, okay. Now in this earth, imagine that at this point we have the hypocenter, that is nothing but the focus, and right above it is the epicenter. Now the waves, they move not just above but in different directions. They go in different directions, but right somewhere in the middle we find the outer core. Now outer core is a molten in nature. Okay, so primary waves, no problem. They go, they come at different levels, and whenever they reach a liquid, remember I told you about primary waves, they can go through solids, liquid, gases. So they come through solids. Now nothing happens. Just because they have to move through another medium, they undergo some sort of a refraction. So they undergo a refraction, again they come back and they make another angle. So up to a certain degree, that is somewhere between 105 degree till 118 degree, you experience a shadow zone, right? Both this side and this side of wherever the earthquake happens. Okay, that is how we can know the radius diameter of the outer core itself, because it's impossible for us to go digging so deep, right? Okay, so and when we come to the secondary zone, I told you that it doesn't travel through solids, liquids, gases. So now what happens? It goes to the outer core, it's not able to go inside because it can't go through liquid, boss, right? So only solid it goes through. So it goes and it makes a shadow zone of 105 degree to 105 degree. Now what exactly is this shadow zone? Now from where the earthquake happens, if I'm on the other side of the globe, I will not experience an earthquake reading, right? I will not experience a seismograph reading. Okay, so this is what is this concept of shadow zone for primary waves and secondary waves. Now I think we have a complete understanding of earthquake and we're good to go. Thank you.